Hello guys, here is the precision setting of the y-axis on the bridge, and this is a inner actuator NSK, and it's 10mm pitch screw, and every time in setting a rail there are 3 readings you have to check or read. The first one is, for example, in this y-axis will be the chop rate of this direction, and to see if it is parallel to the table surface, and I already done it, and by check the block of the dial gauge in this surface, and then the tip of the dial gauge hit the table surface and move it along here. At first there will be variation because this rail is not parallel with the table. Maybe it will incline, tilted up. And for this actuator or rail, it was supported by 4 screws, one here, one here, this block here, and one here, and one is below. And I will adjust this screws until this rail is perfectly parallel with this surface. In doing so, I need to loosen the mounting screw a little bit first, and this is the first step. And the second step is now here, is to measure this rail chopping direction here to see if it is perpendicular with this surface, this reference surface, if parallel with this surface, or perpendicular with this axis, this chop rate of x-axis. And firstly, I need to put a precision granite triangle block here on the table surface, and it is now lift up by 3 ABC block. And in doing the dial gauge measurements, we need to be cautious of its position. And now the tip of the dial gauge is here, is in the center plane of the screw axis. So this position will give the least error. If it is on this position, if this block is at this position and the tip is here, the distance will be largest, and also the tilting or the twisting of the axis will have more error. Here is the minimum error. Even though this axis has some rotation, this distance will have least error. And in checking here, there is also the third reading checking, or need to be taken, is the surface of the moving block. Here I need to move it backward first. the first checking is these two surfaces. If they are in the vertical positions at the same in the same vertical position, I need to use some this metal ruler and see if there is gap on here. So I need to loosen the mounting screw a little bit first to adjust. In doing this two-step checking, I need to loosen the mounting screw first, and also the rear supporting screw stud here. Each mounting screw were supported by two long screw studs. That is the mounting screw will press on the actuator, and in reverse direction, the bottom of the linear actuator will be pushed by these two screw studs. So there is a gap between the bottom of the actuator and the surface of the bridge. And at the first time I need to slightly fastening the two ends mounting screw and the screw studs, and leave all these 1, 2, 3, 4 sets of mounting screw and screw stud all loosened. So I will first adjust the extreme end so that the linear actuator in perfect position. That is, it moves parallel with this surface, and also our vertical correct. These two surfaces are at the same vertical position. Then, after the two ends were checked and correct, and the mounting screw were fastened, all center ones will be fastened in. And in doing so, I will look at this down gauge at each position to see if it is correct at the 0 position. This will be finish the checking, finish the setting, and now I demonstrate the reading here. I move the y-axis. It hits 0 mark. We stop at center position, middle position. Continue. It also 0. So the setting of this y-axis finish. Afterward, I will fill the space between them. The space is around 0.6 to 1.2 millimeter gap, and in doing so, I firstly will use white ink to mark on the screw position, mark on the cap screw top. I haven't done it yet. So each rotation angular position of cap screw will be marked, as well as this position of this screw, all will mark with white ink. Then I will loosen them all and take out this actuator, and then I will lay this machine backward by 19 degrees, so the bridge surface will be face upward. I will lay the epoxy resin on the surface in volume of calculated amount. I will calculate the required volume of resin epoxies from the CAD model first in correct amount and spread it evenly on the surface. Then I put on the rail on it. Once the resin will mix it, once the resin is mixed, the time is critical. It will harden very fast. I think it will harden in a couple of minutes. I need to put the rail back on it and mount all the screws in position that were before, and then turn the machine back in this position and do the final position checking again. Let's do this process again. If there is some minor error, I need to fine tune it. I hope there is none. And the next process is the setting of the final pieces. Is this rail. I will finish all my epoxy filling and the setting processes. Thank you for your watching. If you liked it, and please thumb up and subscribe. And these methods will eliminate all the precision machining of the machine back or the frame. All is done by those adjustable screw studs and the precision checking, and also the filling of the epoxy resin. But the time consumption is very large, and you need to do the machine setting back and forth many times to make sure it is correct before filling the epoxy. Once the epoxy filled, it's difficult to remove it, and I think it may be damaged the precision instruments, the actuator. So I don't want this happen. And before filling the epoxies, I will spread a wax on the bottom of the rail or in the actuator, so the epoxy will stick hardly on the frame surface, on the steel frame surface, but not so hard on the bottom of the rail or actuator. So in case I need to do the second attempt or fail and do the second attempt, I can take out the rail and do it. Of course, I don't want this will happen. Thank you for your watching.